minus 233 degrees Celsius. Sit with that number for a second. That's colder than the darkest Antarctic night, colder than liquid nitrogen splashing across a lab floor, colder than almost anywhere a human being has ever willingly gone. At that temperature, steel turns brittle enough to shatter like glass. Rubber snaps like a dried twig. Skin wouldn't burn on contact. It would just stop feeling anything at all. And floating in exactly that kind of cold, a million miles from the nearest human being, is a mirror. 18 gold hexagons, each one bigger than a dinner table, locked together into something that looks almost alien, built for one job and one job only: catch light that left its source before Earth had even finished forming, light that has been quietly crossing the universe for over 13 billion years just to land on this one surface. Now here's the part that's about to mess with your head. That mirror, arguably the single most important set of eyes our species has ever built, it's made out of one of the deadliest metals on planet Earth. A metal so toxic that the engineers who shaped it had to disappear behind full hazmat suits just to stand near it. A metal where one bad breath, one unlucky afternoon without the right mask on, can quietly scar your lungs for the rest of your entire life, sometimes without a single symptom for 20 years. So really sit with that question for a second. Why would NASA, arguably the most careful, most risk-averse engineers on the entire planet, deliberately choose to build humanity's most expensive, most important scientific instrument ever launched out of something capable of killing the very people constructing it? What do they know about this metal that made that risk worth taking? Stick around, because I promise you, that story ends with a twist that is going to completely rewire how you look at this element forever. All right, here's the deal. Over the next 30 minutes, I'm going to walk you through 6 absolutely insane mysteries wrapped up inside one single element on the periodic table. It's called beryllium, and I promise you, by the time this video's over, you are never going to look at an emerald ring, an X-ray screen, a pair of high-end speakers, or even the night sky the exact same way again. We've got a metal that's basically a ghost to X-rays, completely invisible, like it isn't even physically there. We've got a hidden poison sitting quietly inside actual gemstones people wear on their wedding fingers every single day without a clue. We've got a metal that flat out refuses to rust, no matter how hot you make it, no matter how long you leave it out in the weather. We've got a bell that can ring at a note so high, only a dog standing next to you could ever actually hear it. And we've got an element so unbelievably rare that stars themselves, the exact same objects that forged almost everything else in the universe, simply cannot make it. And we are circling all the way back to that mirror, I promise you that. But here's the kicker. The full story behind why NASA bet everything on this poisonous metal is way weirder, way more dramatic than what I just told you. And it will not make sense yet. Not until you've seen everything else this element is hiding first. So buckle in, because once these 6 pieces click together, that opening image is going to hit you completely differently. Let's get into it. Okay, so first things first, let's rewind all the way back to 1798 in Paris, where a French chemist named Louis-Nicolas Vauquelin was messing around with emeralds and aquamarines in his lab, trying to figure out what made them tick chemically. And buried inside both of those gemstones, he found a brand new element nobody had ever isolated before. He actually almost named it glucinium, from the Greek word for sweet, because the salts of this new element tasted sugary on the tongue. Which, side note, is an absolutely terrifying way to discover a new element, tasting random lab powders. Do not try that at home or anywhere ever again. But here's the twist nobody saw coming back then. That same sweet-tasting element would turn out to be one of the most dangerous industrial substances human beings have ever worked with. Vauquelin had no idea he just discovered a metal that could ruin someone's lungs for decades before symptoms even showed up. That's beryllium for you, sweet on the tongue and lethal in the lungs. Let that contradiction simmer, because it's going to come up again and again tonight. All right, so you know how when you go to the doctor and they slide a plate under your arm and snap an X-ray, you get this crisp, clean, black and white picture of your bones. That happens because pretty much every solid material on Earth blocks X-rays to some degree. Lead is the most famous example. That's literally why they drape a heavy lead apron over your body at the dentist before they zap you. Iron blocks it, gold blocks it, steel blocks it. X-rays hit that stuff and just stop dead in their tracks. Beryllium does the exact opposite. Get this, you can point a full-strength X-ray beam directly at a sheet of pure beryllium metal and it just sails right through, almost like the metal isn't even physically there. Out of every solid material on this entire planet, beryllium is basically the one that acts like a perfectly clean pane of glass to X-rays. And barely anybody stops to ask why that happens. Like seriously, why would one single metal out of the entire periodic table just decide to be invisible to one of the most powerful forms of radiation we know? Here's the answer, and once you get it, it's honestly kind of beautiful. Beryllium sits at position number 4 on the periodic table, which means it's got an incredibly tiny, incredibly lightweight nucleus with only 4 electrons total buzzing around the outside. X-rays get absorbed and stopped when they slam into electrons. The more electrons an atom is taking, the more roadblocks that X-ray photon has to fight through. Beryllium's got almost nothing in its way. 4 measly electrons is basically nothing compared to the dozens, sometimes close to 100, that heavier metals carry. So the X-ray photon just cruises straight through like there's zero traffic on the highway at 3 in the morning. And this isn't just a fun little science trivia fact. This is literally why every single X-ray machine on planet Earth has a razor-thin beryllium window built directly into it. It's the airtight seal that keeps the vacuum tube sealed off from the outside world while still letting every diagnostic ray fly straight through completely unhindered. Every mammogram screening a doctor reads, every dental X-ray checking your teeth for cavities, every airport security scanner peering into your carry-on luggage. There is a razor-thin sliver of this exact element quietly making the whole thing possible, and almost nobody in that waiting room has the faintest clue it's even there. But hold up, because this is where beryllium starts getting genuinely dark. This exact element, the one that lets doctors see straight through your body without a single scalpel touching your skin, it's got a body count of its own hiding in the shadows, and we are absolutely getting there. Let's talk about something you've probably already seen with your own 2 eyes, maybe even touched, without ever knowing what was hiding inside it. Emeralds, aquamarines. You've seen them glittering in engagement rings, sitting in museum crowns behind bulletproof glass, dangling off some celebrity's earlobe on a red carpet. Both of those gemstones are secretly built from the same underlying mineral. It's called beryl, and buried right in the crystal lattice at the center of that mineral is our element, beryllium. Now here's the part that trips people up every single time. In that gemstone form, beryllium is 100% safe. You could wear that emerald on your finger every single day for the rest of your natural life, and absolutely nothing bad would ever happen to you. Same exact logic as table salt sitting on your kitchen counter. Pure sodium metal will violently explode the instant it touches water, but bond it chemically with chlorine, and suddenly you're casually sprinkling it on French fries without a second thought. So no, don't go licking your grandmother's emerald brooch, not because of any of this specifically, just, generally speaking, don't lick jewelry. But the moment you rip that beryllium out of its crystal cage, purify it down into pure metal form, something changes completely, and this is where the story turns genuinely dangerous. The second workers start machining pure beryllium metal, grinding it down, cutting it into shape, sanding the surface smooth, it kicks up this fine, practically invisible cloud of dust, small enough to drift through the air completely unseen. And if a person breathes that dust into their lungs, it can trigger something doctors call chronic beryllium disease, beryliosis for short. And here's the genuinely messed up part. This isn't like a normal poisoning where you feel sick right away, cough, throw up, know something's wrong. Your own immune system basically panics internally and decides beryllium is public enemy number 1, forever, no exceptions. It starts constructing these tiny scar tissue lumps deep inside your lungs called granulomas, and they just keep quietly growing year after year, slowly choking off your ability to pull in a full breath. Some workers get exposed exactly once, a single unlucky afternoon in a poorly ventilated factory, one bad batch of dust nobody caught in time, and the disease doesn't even show its first symptom for 10, 15, sometimes 20 full years afterward. And here's the part that genuinely stumped doctors and scientists for decades. Not everyone who breathes this dust in even gets sick at all. Some people's immune systems just shrug the exposure off completely. Zero problems. Walk away totally fine. But for the unlucky minority whose bodies decide to declare permanent war on beryllium, it becomes a life sentence, a slow tightening around their lungs that never fully lets go. Same element, same dust, same exact exposure. Wildly, unpredictably different outcomes depending entirely on whose lungs it happens to land in. This mystery actually has a dark chapter buried in American history that barely anybody talks about. Back in the 1940s and 50s, factory workers in places like Lorain, Ohio, and Reading, Pennsylvania, were grinding and shaping beryllium for fluorescent light bulbs and early nuclear weapons components, with almost none of the safety precautions we use today. Entire neighborhoods near those factories quietly developed berylliosis just from breathing the surrounding air, not even working inside the plant. It became one of the earliest wake-up calls in American history about invisible industrial dust, and it directly shaped the safety regulations that still exist today. So take a second and really sit with that. A single element, and depending purely on the physical form it happens to be in, it's either sparkling on a queen's finger inside a museum display case or slowly, silently scarring a factory worker's lungs from the inside out, sometimes without them even knowing it's happening until decades later. That's not just chemistry, dude. That's basically a split personality baked directly into the atom itself. All right, but hold up. This is where things get messy in a totally different direction, way less scary though, because beryllium's got another trick hiding up its sleeve. And honestly, this one's kind of impressive rather than terrifying. You know how basically everything metal eventually rusts, right? Leave a steel nail outside in the rain and boom, within a week, you've got flaky reddish-brown crust forming all over it. Silver tarnishes and turns black sitting in a jewelry box. Copper roofs turn this weird ghostly green color after enough years in the weather. That's just the natural fate of most metals. They slowly get eaten alive by the air around them. Beryllium basically laughs directly in the face of all of that. You could heat this stuff up until it's literally glowing red hot in your hand, and it would still come out the other side looking clean, shiny, perfect steel gray, like nothing whatsoever touched it, like time itself just refused to leave a mark. And here's exactly why that happens. The instant a freshly exposed beryllium surface touches oxygen in the air, it almost instantly forms an ultra-thin, practically invisible skin made of beryllium oxide. And that oxide skin is ridiculously, almost unfairly tough. It clings to the metal underneath so tightly, so completely, that once it fully forms across the entire surface, oxygen literally cannot punch through it anymore. It's sealed shut. Game over for corrosion permanently. Compare that to rust forming on a piece of iron, which constantly flakes off in chunks, exposing brand new, unprotected metal underneath. So the rusting process just keeps going and going, layer after layer, forever, until the whole thing crumbles apart. Beryllium's oxide layer refuses to flake off. It just sits there, quietly, like an invisible coat of heat-proof armor that never, ever peels away. It's the exact same basic trick that keeps ordinary kitchen aluminum foil looking shiny for years, except beryllium's version can survive at dramatically higher temperatures, which is a massive part of why engineers love slipping this element into spacecraft components and the guts of nuclear reactors. Real quick before we move on, let's talk about where the stuff even comes from, because getting raw beryllium out of the ground is its own wild story. Most of the world's supply gets cooled from a handful of mines, and one of the biggest sits in Utah, near a place called Spore Mountain, where miners dig up a mineral called bertrandite. Kazakhstan and China run major operations too. But here's the catch. The ore itself only contains a tiny fraction of a percent of actual beryllium. Miners have to crush, cook, and chemically process literally tons of rock just to squeeze out a few pounds of usable metal. And every single step of that refining process kicks up more of that same dangerous dust we've already talked about, which means entire mining towns have had to build their whole safety culture around one invisible threat that most residents will never see, smell, or taste in their lifetime. And that's really the thing about beryllium that keeps circling back around tonight. It's rare enough that entire industries depend on a handful of mines scattered across the planet, and dangerous enough that every single one of those mines has to treat basic dust control like a matter of life and death. Rare and dangerous, working hand in hand over and over again. 3 mysteries down, 4 still to go, but here's exactly where things start connecting together in a way you probably did not see coming. So we've covered beryllium being basically a ghost to X-rays, being a poison quietly hiding inside jewelry people wear every single day, and stubbornly refusing to rust no matter what conditions you throw at it. Now let's talk about what this metal actually sounds like. Yeah, you heard that right. Sounds like. If you somehow took a tiny sliver of pure beryllium and safely shaped it into a small bell, then gently tapped it with a mallet, you would hear a note so insanely high-pitched that a dog standing nearby would register it way more clearly than your own human ears ever could. We're talking frequencies climbing way, way above anything the human ear is even physically capable of detecting. Here's exactly why that happens on an atomic level. Sound travels through any solid material as a wave, basically atoms violently jiggling against their neighbors in a rapid chain reaction, one bumping the next over and over, and inside beryllium, that wave rockets along at almost 12,900 meters per second. That is faster than sound moves through literally any other metal on this entire planet. It's over 3 times quicker than sound travels through solid steel. Picture a jump rope for a second. A short, tight, rigid rope flicks back and forth insanely fast when you snap it. A long, floppy, loose rope just kinda lazily flops around in slow motion. Beryllium's internal atomic structure behaves exactly like that short, rigid rope, remarkably stiff, remarkably lightweight at the same time, so any vibration traveling through it oscillates at frequencies climbing way up into the ultrasonic range, territory only bats and dogs can actually hear. And this isn't just some cool party trick for science nerds. Audio engineers actually build real products around this exact property. High-end speaker tweeters, the tiny domes responsible for pumping out your highest, crispest frequencies, are sometimes literally manufactured from paper-thin beryllium foil, specifically because it reproduces sound with insanely precise clarity and almost zero distortion. We're talking about speaker systems that cost more than a used car sitting in someone's driveway, and beryllium as the secret weapon quietly humming away inside them. But here's the genuinely tragic part of this whole thing. That same toxic dust we talked about a couple mysteries back, yeah, that's exactly why you're never gonna find a cute little beryllium wind chime hanging peacefully on somebody's back porch. This metal sings like an actual angel, and it has to be handled like it's practically radioactive the entire time. And it's not just speakers either. Golf club makers experimented with beryllium copper alloys in club heads for years, chasing that same stiff but light combo, trying to squeeze a few extra yards off the tee. Some high-end bicycle frame builders did the same thing, hunting for a metal that could survive brutal mountain trails without flexing and wasting a rider's energy on every pedal stroke. Even orchestral musicians got curious. A handful of experimental cymbals and mallets have been built using beryllium alloys over the decades, chasing that impossibly bright, piercing overtone that regular bronze and brass just can't quite reach. None of it ever went fully mainstream, mostly because of cost and, you guessed it, that same dust problem creeping back into the picture yet again. Okay, pause with me for a second here because I need you to notice something that's been quietly hiding underneath every single mystery we've covered so far. Every one of them keeps circling back to the exact same 2 words: light and stiff. Beryllium is unbelievably lightweight and unbelievably rigid at the exact same time. That combination almost never happens naturally. Usually, stuff that's feather light is also kind of flimsy and bendy, and stuff that's rock solid and rigid tends to be heavy as bricks. Beryllium completely shatters that rule. And that exact combination is exactly what makes this metal so dangerous for human beings to physically work with. And it's exactly the same combination that's about to explain why NASA gambled an entire space telescope success on it. Remember that cold open from the very beginning? We are circling directly back there, but not quite yet, because first we've got to answer the single biggest question of the entire night. Where does this element even come from in the first place? So here's something genuinely wild that most people never think about. Beryllium is element number 4, just 4 protons total sitting in its nucleus. That's about as basic, as stripped down as an atom can possibly get. You'd naturally assume something that's structurally simple would be scattered all over the universe in massive quantities, right? Nope, dead wrong. It's actually one of the single rarest elements that exists anywhere in the observable cosmos. Think about the universe's cosmic recipe book for a second. The Big Bang itself cooked up hydrogen, helium, and just the tiniest sprinkle of lithium, practically nothing else. Then stars ignited across the universe, and deep inside their blazing hot cores, they started fusing those handful of simple elements together into progressively heavier stuff: carbon, oxygen, iron, basically every single element that ends up making up planets, oceans, mountains, and every living thing, including you. But beryllium never got an invitation to that particular party. Anytime a star's white-hot core attempts to fuse together a beryllium atom, it collapses right back apart again almost instantly, practically before it even finishes forming. It's this incredibly fragile nuclear stepping stone that simply cannot hold itself together under normal stellar conditions. So regular stars, the exact same objects responsible for basically every other element surrounding you right now, end up producing next to zero beryllium over their entire lifetimes. So then how does beryllium exist at all? Get this, it's actually born out in the freezing, empty vacuum of space between the stars, not inside them. High-energy cosmic rays, which are essentially protons blasting across the galaxy at speeds close to the speed of light, slam violently into heavier atoms like carbon and oxygen, drifting quietly inside interstellar gas clouds. That collision shatters the larger, heavier atoms apart into fragments, and buried somewhere in that wreckage, tiny scraps of beryllium accidentally get stitched together. Scientists actually have a name for this process. They call it cosmic ray spallation, and it is brutally, almost comically inefficient. Picture trying to build an entire house by hurling bowling balls at a brick wall from across the street and just hoping a few loose bricks happen to land in roughly the right shape. That's basically what's happening out there in interstellar space, and that's exactly why beryllium ends up being one of the rarest elements in the entire known universe. Every single atom of it that exists anywhere, inside your phone's electronics, inside a sparkling gemstone, inside a billion-dollar space telescope floating 1,000,000 miles from Earth, is a leftover fragment of some violent, silent collision that happened somewhere out in deep space, not a product of some star's internal furnace, like almost everything else around you. Let that fully sink in for a second. This metal never once came from a star's blazing internal forge. It came from cosmic wreckage, from random violent impacts scattered across the emptiness between galaxies. And that extreme rarity, combined with everything else we've walked through tonight, the feather-light weight, the insane stiffness, the hidden poison, the stubborn resistance to rust, is about to collide together in the single most unbelievable engineering precision in modern space history. So, picture the James Webb Space Telescope one more time. 18 massive hexagonal mirror segments coated in a whisper-thin layer of gold, sitting on a heart of pure beryllium, floating nearly 230 degrees below freezing, positioned way out past the moon's orbit, quietly catching light that left its source before planet Earth had even fully formed. Here's the question that should genuinely be bugging you right now. Why on earth would you build the most expensive, most scientifically important instrument ever launched into space out of a metal that can permanently scar the lungs of the very people constructing it? Because nothing else on the entire periodic table could have survived where it was going. Out there, past the moon, the temperature is so brutally, punishingly cold that most materials shrink, warp, and subtly twist just enough to throw the mirror's precision focus completely off. Ordinary glass, the exact material basically every telescope built on Earth relies on, would warp under those extreme conditions and ruin the entire mission before it even started. But beryllium barely moves at all. It expands and contracts so minimally with dramatic temperature swings that at those extreme cryogenic temperatures, it simply locks itself into its exact intended shape and stays completely still. And remember that whole light but stiff combination we kept bumping into, mystery after mystery? That's precisely the reason this entire mirror could even be launched into space in the first place. It's light enough to physically survive the brutal violence of a rocket launch, yet somehow so rigid that it barely bends under even its own weight, despite being stretched out to the size of a small building. So NASA's engineering teams had to make what genuinely felt like an impossible call. On one side of the scale, a toxic dust demanding fully sealed, ultra-clean rooms, complete protective hazmat suits, and years of unbelievably careful, methodical handling just to safely shape the raw metal into mirror segments. On the other side of the scale, the only material anywhere on Earth capable of holding a flawless, unwarped shape in the punishing, freezing darkness of deep space.
They chose the danger every single time. And the reward for that terrifying bet was the deepest, clearest, most breathtaking image of the universe humanity has ever managed to capture. Ancient galaxies from the literal dawn of time, caught and reflected by a mirror built from one of the most hazardous metals known to modern science. But here's a detail that barely makes it into the headlines. Building those 18 mirror segments took years, not months. Engineers had to machine each hexagon into shape, then cool it down to the exact freezing temperature it would experience out in space, then measure it with lasers accurate to a fraction of the width of a human hair, then warm it back up and shave off microscopic imperfections, and repeat that entire brutal cycle again and again until every mirror behaved exactly as predicted at cryogenic temperatures. One wrong measurement, one overlooked warp, and the whole telescope would have launched 1 billion miles into space with blurry vision it could never fix. There was no repair truck waiting out past the moon. They had exactly one shot to get it right, and beryllium was the only material steady enough to make that one shot possible. And honestly, that telescope isn't even the only place this element quietly slipped into. Fighter jets use beryllium alloys in their guidance systems because the metal barely expands or contracts with heat, keeping targeting systems locked in perfectly even during violent high-speed maneuvers. Oil rig workers, standing inches away from flammable gas that could ignite from a single spark, use wrenches and hammers made from beryllium copper alloy, specifically because striking that alloy against metal produces no spark whatsoever, unlike ordinary steel tools. For years, Formula One teams quietly built engine components out of beryllium alloys until the sport's governing body banned it entirely, worried that teams with deep enough pockets could buy a genuinely unfair performance advantage nobody else could compete with. And deep underground at CERN, inside the Large Hadron Collider, the beam pipe positioned closest to the actual particle collisions is built from beryllium, for the exact same reason as those X-ray machines we talked about earlier. It needs to be almost completely invisible to the high-energy particles screaming through it. So here's where it all finally comes together. 6 mysteries, one single element. A metal that's practically invisible to X-rays, but became visible enough to build the ultimate instrument of scientific discovery ever launched off this planet. A poison locked safely away inside gemstones that people wear without a single second thought. A metal that flat out refuses to rust, that rings at frequencies only dogs can hear, that was never even born inside a star, but instead violently assembled from cosmic wreckage, drifting silently in the emptiness between galaxies. Beryllium breaks basically every single rule you'd naturally expect a simple, lightweight element to follow. It's a transparent window and an opaque poison existing inside the exact same block of metal. It's a jewel's glittering heart and a factory's greatest silent hazard. It's a cosmic outcast rejected by every star in the sky that somehow ended up building humanity's window into the birth of the entire universe. And honestly, that's the real mystery hiding underneath all of this. Not any one single fact by itself, but the sheer fact that all of these wild contradictions manage to live quietly inside the exact same tiny atom.
4 protons. That's genuinely all it takes to hide this much complexity, danger, and beauty in one place. So the next time you scroll past a photo from the James Webb Space Telescope, or spot an emerald ring glittering under store lighting, or sit still for an X-ray on a doctor's screen, remember, there's a real chance beryllium is quietly sitting behind all of it, doing something absolutely nothing else on the periodic table is capable of doing. And if you thought this element was wild, just wait until you see what's hiding one single square over on the periodic table. That one's got a personality all its own too, and trust me, it's just as unhinged. See you in the next one.